Model direct variation. So we're starting on page 253, and what we're going to talk about is this idea of how numbers vary with one another. So that's the example here of the description. It says here, two variables, x and y, show direct variation, provided y equals ax and a is not equal to 0. The non-zero number a is called the constant of variation, and y is said to vary directly with x. So this is sort of like slope, but with a specific situation where you don't, where the actual the y-intercept is equal to 0 as well. So so the equation y is equal to 5x, I'm still reading here, is an example of direct variation. The constant of variation is 5. The equation y is equal to x plus 5 is not an example of direct variation. So that kind of makes sense there, hopefully. And then just as examples here, it says here 2x minus 3y is equal to 0. So you're supposed to tell whether it represents direct variation, and then if it does, solve and try and figure out what that variation is. So let's rewrite this out. 2x minus 3y is equal to 0. So we're going to subtract 2x from both sides, so we end up with negative 3y is equal to negative 2x, and divide both sides by negative 3, we end up with y is equal to 2/3, not negative 2/3, because we're dividing negative 2. So yes, there is constant variation, and the constant variation is direct variation, and constant variation is 2/3. For this one here, negative x plus y is equal to 4. Let me fix that. Then y is going to be equal to 4 plus x plus x. There's no constant variation because you got that extra 4 on the side, so that doesn't work out that way. So looking at these quickly down at the bottom, this one here, negative x plus y equals 1, so that's going to be y is equal to 1 plus x. So no, there's no, it's not direct variation because you've got that 1 there. So the next one, 2x plus y is equal to 0. So y is equal to negative 2x. Yes, there is a constant of variation, and it's negative 2. So there's direct variation and constant variation. The last one, 4x minus 5y is equal to 0. So negative 5y is equal to negative 4x. So it's going to be y is equal to 4 divided by 5x. So yes, there's a constant of variation. It's direct variation. There's a constant of variation. That's 4/5. So next up, it says here, notice the direct variation y equals ax is a linear equation in the slope-intercept form of y equals mx plus b, where m is equal to a and b is equal to 0. So just like I said, the y-intercept is 0, and the value of b of m is actually equal to a. So the line passes through the origin. So that's actually one of the easiest things to do when you're plotting points using these, because direct variation, for example, here it says y equals 2/3 x. It's actually easier to graph than any other linear equation a lot of ways, because you know that the origin 0, 0 is going to be a point. And then what do? You go up 2, so it's going to be 2, and you go over 3, so that's going to be a point 2. Up 2, over 3. Up 2, over 3. And you see what I'm doing? Each time I'm adding, for the y, I'm adding that, and for the x, I'm adding this. And so that should give you a nice straight line. And that's basically how you do it. So next one here, again, point is going to be 0, 0. That's the first point. In this case here, we're going to go over 1 and down 3. Over 1 and down 3. Over 1 and down 3. So that's where we're at. That's how that works. So in the example here, it says the graph of direct variation is shown for that. Write the direct variation equation when the value of y, find the value of y when x is equal to 30. Okay, so if you look here, we should be able to figure out the actual direct variation, or the actual constant of variation, because we've got a point there and then we know it's going to go through 0. So to figure out the slope, well, we're just going to go and the actual variation is going to be, well, it's -1, and it's actually in the example there. So I just switch this around a little bit. Y equals AX, that means that A is times -1, because I'm just plugging in a point that's on the actual line, is equal to 2. So when I solve for it, A is going to be equal to -2. So then I can just plug that back in, so it's Y is equal to -2x. So when X's value is 30, it's going to be -2 times 30 is equal to Y, so that's going to be -60. So that's how you figure out these sort of examples when you graph something like that. Key things to understand, yes, just like with slope, you have these values here. If it's a positive slope, if it's a positive value of A, then it'll kind of go uphill from left to right, if you want to think about it that way. And if it has a below 0 slope and negative slope, then it's going to go downhill from left to right. So now I get to this example of an aquarium. The number S of tablespoons of sea salt needed in a saltwater fish tank varies directly with the number W of gallons of water in the tank. Pet shop owner recommends adding 100 tablespoons of salt to a 20-gallon tank. That is a lot of salt. Write the direct variation equation that relates W and S. Okay, so we know that it says here, well, W and S, W is the amount of gallons of water in the tank, so W. And we're trying to figure out the amount, and so S is the amount of salt. And then we have A, that's the constant of, that's the variation. So, so then we just plug in the numbers. 100 is equal to A times 20. So A is going to be equal to 5. And that's how you do that. So, so that's just one example of how to figure out A. And now, if you, it says here, how many tablespoons of salt should be added to a 30-gallon saltwater fish tank? You might be able to figure that out anyhow because, well, it's 20 gallons plus 1/2 more of that, and so it's 150 gallons. But now you've got this value of A, so you can just go ahead and put that back in. So it's A times W is equal to S. Now we know 5 is that, so we've got the amount of gallons, so it's 30 is equal to S. Sorry, that's a 5 there. So it's going to be 150 is equal to S. And that's how it works. So